Hey everybody, this is Larry. This is the last day of the October Leetcode Challenge. Yay, happy Halloween. Hope the world is not too scary this year or whatever. Let's go over today's problem. We cover binary search tree. Hit the like button to subscribe and join me on Discord. Let me know what you think about these silly puns. But you're given the root of a tree where exactly two of the nodes is swapped by mistake. We cover the tree without changing its structure. Okay, so that's going to be an annoying one. Okay. I mean, so binary search tree has an invariant where everything on the left everything on the left side of the subtree is smaller than the root, and everything on the right side of the subtree is bigger than the root, right? So that's kind of the invariant we have, and given that n is equal to 1,000, we can actually do something brute forcey. And what I mean by that is just by n squared, you can find which two numbers for which this is not true. Right? And then just construct it that way. Otherwise, a solution using O(n) is pretty straightforward. Is that true? It's still really annoying though. But well, I'm trying to think whether I can do it in a clever way. Can you do a constant space solution? Let's see. How can I do this in constant space? I always find the constant space one a little bit annoying, but in this case we know that it is the 3, but well, I guess you could find one number pretty quickly. Can you find the other one just as easily? In this case, because in this case, the 3, well, I guess it's just 2 violations, but that's not always true, right? Because in this case, I guess only 2 examples. But in the second case, the 2 is not really in violation except for compared to the 3. So that's kind of okay, but annoying. So yeah. Let's see. Oops. So yeah, I mean, I think the way to do this in constant space is by using the Morris traversal. That's probably the only way to get in constant space. And anytime someone asks you constant space with respect to a tree, that's how you would do it. So I think that's it. What I'm going to do is I still have a refusal to learn Morris traversal because it really only comes up like really rarely, and it's not one of those things. I think it's one of those things that just comes up more recently. So maybe it is on my to-do list to learn and maybe to teach. But for now, I'm just going to do it the DFS way. And I saw this problem relatively recently, but on one of my Twitch streams. So, but I think my concept was that for every node, I look at the left. The min node, which is just a node to the left, and then the max node, which is the min node that's smaller than this node, and the max node that's bigger than this node, right? So basically, given the root, you're just giving the previous and the next in order traversal, right? Which is actually pretty much how Morris traversal would work. But yeah, and then from that, I can get which 2 numbers are off, and then I can I should be able to get the number. So let's start it off, and then just swap it. I mean, yeah, and I could do min by node, say, because I think I've written something similar recently. This is for a node, the min number that is bigger than this node dot value. And this is for a node, the max number that is bigger or smaller than this node dot value, right? And then you just have something like this. So I will have, if node is none, this is just very standard depth of search stuff. I'm trying to figure out how to make this bigger, but this feels a little bit claustrophobic right now, but that's okay. Yeah, so we could do a depth first search node dot left, depth first search node dot right. You probably could do this in order, but that's how you're gonna do it. Okay, so that's how you create more space. So I could scroll down a little bit more. Okay. And then okay, if node dot left is not none, then we check. Then we get the then basically we do essentially like a dynamic programming thing, because the max of the left is just going to be the max of the left node, right? Yeah. I think that's right. Basically, well, let's keep track of this first. What do you want to do? Okay, let's just say min by node of node. Oops. Does it go to node, max by node? This is just the default case. And then if node dot left is not none, then and by this depth first search we already should be processed the min. So so if min by node of node dot value is greater than min by node of node dot left dot value. But basically this is very dynamic programming-y. Oops. Kind of, yeah. And then we do the same for max. Basically getting the max value, we propagate the max value up. How did that? Per node. Maybe this is actually wrong. Actually, I think what I want. Well, I mean, it's still going to be true. Oh, sorry. The number that's for a node, get the min number of this subtree, of this node's subtree. And then we could figure out that way, I think. Maybe that's straightforward. And then we just, this is very code intensive, so I'm not a fan of it. But maybe one day I'll learn the max, oh sorry, I'm just going to copy and paste a little bit. Maybe one day I'm going to learn the Morris traversal. Because I think that traversal code is slightly easier, but I mean, I've seen it before. I just haven't done it before still, so I don't really want to swap it out. Okay, so this will get, now we know the subtree. So then, okay, I think we should check first, because otherwise, because basically the idea is that okay, if the smallest value of this subtree, how do you say it? If the biggest value on the left subtree is bigger than this node, then you have to swap these two, right? Is not none. Then if max of by node of node dot left dot, so this node is bigger than node dot value. Well, okay, let's just do an answer to nodes to swap. Let's go to then we know that this is just maybe just none. Node and max by node of node dot left, that's fine. And then we do the same for the right, which is that if the min number on the left, on the right side is less than node dot value, that means that we have to swap these. Are these order cases? I think that should be it, maybe. I mean, and then we can do the first search of the root, and then we swap the nodes.swap. So we just do something like do. I guess we can do something like this. Oops. In Python. And then that's pretty much it. None type. Oh yeah, if well, this should definitely happen at least once. So we'll see what happens. We'll add some debugging, but I would not check a none because that means that there's no answer. Unless there is possible. Exactly 2 nodes. Okay, so yeah. Let's see. Okay, well, do we do this at all? I think we need a non-local in here. Actually, don't know if that fixes things, but we'll see. No, it does fix things. I thought it would complain though about. Maybe not. Maybe that's fair. Let's put in the other test case. But I would say, even though I did it with depth first search and OFN space, 231 was 231. Oh. So then if you swap these, it would just give you. Well, I guess it depends on which one you swap, but it's still wrong. Okay. I mean, I know we could swap these two, but does that always hold? Okay, let's add that in. If node.left is not none and node is not none. If the min by node on the node to the right is greater than max by node to the left, then nodes to swap is equal to node. Oops. No, it's equal to min by node dot right. Max by node dot left. I think this could be done also if I had just put this before this, because then this would just check that anyway. But maybe. Oh, I should put this one in there. Dot value. Okay. Oh. That's not right, right? What is one? I don't know. They don't show me the visualization. This is not right though, right? Nope. Why is this not using this swap instead? If the min on the right and min on the left, then you swap them, right? That's weird. Let's test this. Swap left, right. That is a thing. Do I have a typo? Why doesn't this let me double check that it's also this one. Why doesn't this hold? So input, we swap the 2 and the 3, is that right? Wait, do we? Oh no, we swap 1 and 2, okay. But why don't we swap this? And we could also just move this here. I guess this isn't not an input. This is still 132. Huh. Did I mix them up? No, this should definitely be very confused, but the min, yeah. Oh, I'm thinking of the wrong. Wait. Now I just have the signs wrong. This should be, if this is less than, I'm not thinking, it's 3:30 a.m. So that's my excuse. Because if this is small, if your right side number is smaller than your big side number, then you swap. Yeah. Okay, I am just being silly. Okay. Is that okay? So that looks good. Oops. Did I mess it up? Because I did some undos. If the last number is, yeah. Sorry, friends, for that delay. Let me test again though, because testing is still fundamental and I don't want to get a wrong answer. Oh, you missed the case. Okay, looks good. Let's submit. Cool. Yeah, so this is linear time, linear space. It's linear time because we do a depth first search and we look at each node once. And it's linear space because the min by node and max by node is also O of n. And if you kind of see how this goes, you can actually do a Morris traversal and look at just like 3 nodes at a time or something like that. And I think that would, be all the possibilities, maybe. But because 2 numbers will be out of place. But maybe I'll learn that one day. Yeah, that's all I have for today's problem. Let me know what you think. Hit the like button, hit the subscribe button, join me in Discord, and I will see y'all next month. Yay! End of the month. I forgot. Yay! All right. Bye bye, friends. Hope you had a good month.